This is your teacher Jenny again for another topic. This time we are going to talk about the introduction to hyperbola. Hyperbola is a set of all points in a plane in which the difference of distances from two fixed points is a constant. So the two fixed point that we are referring here is what we call as the foci. This is similar to our ellipse, only that we are just simply having our difference here. There are parts of hyperbola. First, we have the center, your HK. This is a point located at the middle of the hyperbolic graph. So if this is your hyperbolic graph, the center is this one here. This is located in the middle of that hyperbolic graph. The other part of the hyperbola is the vertices. So the vertices are said to be two vertex points whose segment forms the transverse axis. Based on the past lesson on the different conic section, I think we are so familiar with the vertex points or the vertices because once you've got a hyperbolic graph like this, you have the vertices as the turning point of that particular graph. So in this particular example, we have that one here. This one is one vertex. This one is another vertex. So these are the turning points of our graph. And if we are going to join those two vertices together, we will be viewing a line segment which passes through the center. And this line segment here, that is what we call as the transverse axis. So again, transverse axis is a line segment joining our vertices. Another one is the foci. So once you say foci, that's plural form for focus. So most likely when we deal with parabola and then we deal with hyperbola or the ellipse, we have our focus in which this is where, or this is a point located to where our graph is opening. So since we have a hyperbolic graph here, we have two somewhat like a parabola graph, and then you've got the focus here, which is located in here, in which that one is opening towards two, and this one is another focus in which that graph here is opening towards two. So again, hyperbola have two focus in which we will be locating that one to where the opening of the graph is. Next one, we have the covertices. Covertices, similarly with the ellipse, we have covertices here. Covertices, they are two co-vertex points whose segments forms the conjugate axis. Our co-vertices here, once we join that one, or once we connect that one, this is our co-vertex, and this one is the other co-vertex. So once we join that one, this will be forming a line segment in which we call that one as conjugate axis. Again, conjugate axis, that's a line segment which joins our co-vertices. We have also the principal axis. The principal axis is a line that passes through the vertices, the foci, and the center of the graph. So if we are going to locate our principal axis here, principal axis is the line segment or a line that passes through our vertex, foci, and so with our center. We have also the reference rectangle because in graphing our hyperbola, we will be guided with the use of the reference rectangle. Reference rectangle is a rectangular figure formed by tracing the vertices and the co-vertices. So later on, we will be dealing with that one once we are graphing our hyperbola. But to illustrate that one, the reference rectangle here can be drawn by simply connecting our vertices and co-vertices. So let's say, for example, this one here, we can simply have this one here, a line segment that passes through our co-vertices and a line segment that passes through our vertices, in which this would somehow be forming a rectangle. So this rectangular reference, or the reference rectangle here, this would somehow guide us to our asymptote, to to where particularly is our graph be drawn. So this will serve as our guide, because later on, once you have the reference rectangle, you will be drawing the diagonal of that one. In this case, this one is our diagonals of that reference rectangle. This will guide us as to where our graph will pass through or will be asymptotic to. We have asymptotic line, as I mentioned from before. We've got an asymptotic line here in which this will serve as a diagonal of our reference rectangle. Later on, I'll be showing that one in another video. So we have here reference lines of the graph. The hyperbola approaches these lines but will never intersect them because they are asymptotic. They never touches that particular reference line. There are different properties of hyperbola. First, we have the result of subtracting the distances from two fixed points is always constant. So if we try to subtract the distances from one point to our focus, and then another point to a focus, that will always be the same value all throughout the graph. Next one, the distance from center to vertex is denoted by A. So the length of the transverse axis is 2A. Now, here it's different from the ellipse wherein we are viewing our A there as the bigger value. We are viewing our A here could be either bigger or not. So it's kind of different. So again, we've got transverse axis. The length of the transverse axis there is 2A. Because our distance from the center to the vertex is A. And B here is the distance from the center to our co-vertex. And the length of the conjugate axis is 2B. The distance from the center to a focus is denoted by C. So the length of the foci is equivalent to 2C. So those are the different properties